Alright, two things you need to know in addition to the basic sine, cosine, and tangent things that I just went over. Two things you need to know for the second meets round 5. The law of sines and the law of cosines. The law of cosines says basically this. You know how smaller angles end up opposite smaller sides and bigger angles end up opposite bigger sides? It's because if a side is sort of closed, the two things, like let's say there's 3 people standing around. Bob, Harriet, and Laura, who also wears pants. Because why do only men get to wear pants? Okay, so let's say one of them is standing pretty far away from the other two. For that person, those two seem to be standing pretty close together. The angle, looking from one person to the next, is pretty small. Because, compared to him, they're closer to each other. So small angles end up opposite small sides. She, on the other hand, really has to turn her head to look from one person to the other, because these two are, compared to that, further away. So the angle, any angle is related to how big the opposite side is. A small angle is opposite a small side, a big angle is opposite a big side. So now let's say I know that this is 8 inches long. It's opposite a 45-degree angle. And this is the relationship between sides and angles. Basically, the sine of a 45-degree angle is to the length of the side opposite it, just as the sine of this 60-degree angle is related to the side opposite it. So if I want to find this side, I can do that using this equation. The sine of 45 degrees is root 2 over 2. Then divide by 8 would give you root 2 over 16. Sine of 60 degrees is root 3 over 2 divided by x. I'll multiply both sides by x. And I'll multiply both sides by 16. Cross multiply. And I end up with this, and then I'll divide each side by root 2. And I'll rationalize this by dividing both top and bottom by root 2, and I will end up with 4 root 6 equals x, and I have figured out how long this side is. It's 4 root 6 inches. So that's how the law of sines is used. If you know 2 angles and one side of a triangle, or if you know 2 sides and one angle, you can find one other side or angle. Really what this is it's an application of angle, angle, side. When you know 2 angles and a side, you can find out other things about the triangle. Now we know another side. If we wanted to, we could figure out this angle, 45 and 60, that means this is 75. And then if I knew by heart the ratio for 75, I'd be able to find this side. I'd need a calculator for that myself. So that's the application of the law of sines. Basically, if you know 2 angles and a side, you can find out one by one everything else about a triangle, or 2 sides and an angle. You can do the same, unless, stick with it, you'll be able to use it in math team. Now let's take a look at law of cosines. Law of cosines is a modified Pythagorean theorem. So if this were a right angle, you know how Pythagoras only works for right triangles? It's because if, in a right triangle, certain things are true between these 3 sides. But if you made it not a right angle anymore, it wouldn't be true. This third side would end up longer if you made it obtuse, or smaller if you made it acute. So what this is this is basically Pythagoras, a squared plus b squared equals c squared, with a modifier that changes things when this isn't 90 degrees. See, the cosine of a 90-degree angle is exactly 0. So when you have a 90-degree angle, this basically goes away. It becomes 0 and it's gone, and you have Pythagoras. So Pythagoras is really a special case of the law of cosines. This works even when the one angle we know is not a right angle. If it was a right angle, we'd go 12 squared plus what squared is 20 squared, done. But in this case we can't do that because it's not a right angle. But we can still calculate it using this law. I will declare this to be the angle opposite C. This will be A, B, and C. Because the angle opposite C is what goes into cosine. So, A squared, 12 squared is 144. B squared, that's what we are going to figure out. We're going to figure out the length of this side. 2 times A times B, which we don't know, times the cosine of angle C. What's the cosine of 120? Negative half. C squared, 400. And you can see this is solvable. This is a quadratic equation that's about to be simplified if I want to simplify it, and I can solve for B. Right? This comes out positive 12b, b squared plus 12b minus 256 equals 0. And you can solve that and get yourself a value for the length of b. And only one of them will be positive, the other one will be negative, and you'll ignore it because b can't be negative. More often than that, it's used to calculate the length of this side. Let's say I told you that this was 18 inches. This is even easier. Notice that this is a realization of the side angle side theorem. If we know two sides and an angle between them, we can figure out everything else there is to know about the triangle. We can't use law of sines because we don't have a side opposite this angle to use for that. But now we can use this instead. A is 12, so this would be 144. B is 18, so 324. That times that is 216 times 2 is 432. Cosine of angle C, that's negative half, equals C squared. This is C. Those add, well, this is 216. This is 468 equals C squared. When we subtract them, we get 252 equals C squared. Then we square root them and we get root 252. You could simplify it if you wanted to. It can be simplified. 9 can be cut out, for example. Equals C. And you would simplify that. I'm not going to bother doing that right now. You know how to simplify square roots, I hope. And yeah, that's how we find the length of a missing side in a triangle like that using law of cosines. So again, in these problems, I don't know what you're going to end up with, but draw a picture. And you'll generally find that either the law of sines applies, where you know a side and an angle opposite it, and then one more side or one more angle, or more of a side angle side situation, in which case you'll need the law of cosines, because you don't have a side and an angle opposite it. You have two sides and a different angle not opposite it. Yeah, so that is basically that section. Know your sine, cosine, and tangent for any degree on the unit circle pretty much. And know the law of sines and the law of cosines and how they're used to find your way around triangles.